Find the position of load W such that the member AB remains horizontal. The arrangement is as shown in the figure. So, and suppose the load is applied at a distance of x from this particular support. So, remaining distance will be B minus x. So, this bar has to be remain horizontal. Now, here it is supported by two rods. One is copper rod of 1.6 mm diameter. Modulus of elasticity of copper rod is 125 GPa. Here it is steel rod of 0.9 mm diameter, and modulus of elasticity of steel is 200 GPa. And we have to find out what will be the distance x in terms of B, so that this particular rod AB will remain horizontal. So let us draw the free body diagram and apply the conditions of equilibrium in this particular case. Suppose the first condition of equilibrium is summation of Fy is equal to 0. Upward forces positive, downward forces are negative. So load in copper, which is the reactive part. So this is the reaction offered by the rod, copper rod and steel rod. So PCU plus PST, they are acting in the upward direction. They are supporting this particular bar. And load W is acting in the downward direction. Downward forces, they are considered as negative. So PCU plus PST minus W is equal to 0. Transfer this negative value on the other side, it will become positive. That is our first equation. Now summation of moment about this support is 0. So clockwise positive and anti-clockwise negative. So this PST, this W, it will produce clockwise moment. So we can see this arrow of W will go towards C in clockwise direction. So force multiplied by perpendicular distance. So this is vertical, horizontal distance is the perpendicular distance, that is x. So W into x, this is the clockwise moment, so it is positive. Whereas this PST, it will produce anti-clockwise moment about C, so it is negative. So minus PST into B. PCU, it passes through C only, so it will not have any moment. Transfer this negative term on the other side. So Wx upon B will be equal to PST. Now from equation 1, PCU is equal to W minus PST. So this is PCU. So W minus PST is nothing but Wx upon B. Take W common from both these terms. So it is 1 minus x upon B. Cross multiply by this B over here. So B into 1, that is B minus x whole divided by B. So these are the values of PST and PCU. Now for AB to remain horizontal, deformation in copper has to be equal to deformation in steel. Then and only then it will remain horizontal, otherwise it will be in the inclined position. So PL upon AE of copper has to be equal to PL upon AE of steel. So PCU LCU upon ACU ECU of copper will be equal to PL upon AE of steel. Now length is same, so that will get cancelled out from both the sides, and PCU will be equal to cross multiply by these two terms over here to this PST. So this ACU ECU term will get cross multiplied to this PST. LCU and LST we have cancelled out, divided by AST into EST. Now substitute the value of area of copper, that is pi by 4 dc square. Area of steel is pi by 4 ds square. Pi by 4 will get cancelled out. Substitute the values of DC, then ECU. DC is 1.6, ECU is 125 into 10 raised to 3. DS is zero point 0.9, that is diameter of steel, into EST, that is modulus of elasticity, is 200 into 10 raised to 3. So that will get the relation between PCU and PST, that is PCU is 1.97 times PST. But we know that PCU is nothing but WB minus x upon P, and PST is nothing but WX upon B. Cancel out this W from both the sides, this B from both the sides. So it is B minus x, which is there in the numerator, will be equal to 1.97 into x. W we have cancelled and B also we have cancelled. Now transfer this minus x on this side, it will become positive. So it is 1.97x plus x, that is 2.97x is equal to B. So B upon 2.97 will be the value of X. So this is the position of the load W so that the rod AB will remain horizontal.